So the substitution rule, so this is the method we will study today, substitution rule. So the method will, it's a method of integration that allows to simplify some, transform some integrals to compute antiderivative to simpler ones. For example, how can we find an antiderivative of the 2x square root of 1 plus x2? So we will be able to answer to how we can do x3 plus 1 power 100 and 3x2 dx. So this kind of we will have answers to this kind of computation. So here is the theorem. It says the following. So if the function u, g of x, g, okay, is differentiable on the set of image of g. Now is differentiable, okay, on an interval I, okay. No, sorry, not that. Isn't it is differentiable and not, okay, it's differentiable somewhere on an interval, and the image, so the range of G is an interval, is included, so it's an interval, let's say interval that is included in the domain of function f. So here we have this. We have the following situation. So we have g. So it is defined somewhere, or takes its values. G, the range of g is included in the domain of f. Then we have the function f. So we can form here the composite function f of g of x. Okay. So that's why we need to check these inclusion satisfied. Then yes, we need f continuous on the interval I. Let's say an interval I on I. Then the theorem says that computing an antiderivative of function that is in this form, that you can see that it looks like something like that, then f at g of x, then g prime d is exactly f u du. Okay, so this is what the theorem says. And the proof, let's see, have a look at it. It's a nice one. So so f has, since f is continuous, then it has an antiderivative set. So set fx, an antiderivative of f t dt. Okay, so we have f prime of x is f at x. Now we want to show this equality. So let's start from the left side, hand side, and write it differently using the antiderivative, capital F. So look what happens here. You will have f prime at g of x, g prime of x dx. But then this reminds me of chain rule formula. Okay, so I can see that I have I can write it f of g prime at x dx. Okay, And now an antiderivative of f of this function is f of g, and the general one plus a constant. Okay. Okay. Yes, and this is what we can write differently if you want. Okay. Yes, we can write it as f at u, okay, plus c, which is f u du. Okay, so this is what the theorem says. Okay, so let's answer to find the answers, or for the examples we set at the beginning. So, for example, if I am asked to find an antiderivative of this function. So let's identify. I see if you have a composition and something g prime. So I need to identify f and g. So my f, I see that I can, if I consider square root, which is the f, and inside here is my g. Yes, this one then will be g prime. So yes, I can write it as f, which is so the square root f at g of x times g prime of x dx. So it is, yes, an antiderivative. So it finally it comes to use find fu du, but then fu is just square root of u du, and this one is a power function. We know how to compute an antiderivative. So it's u 1 over 2 plus 1 over 1 over 2 plus 1 plus c. Okay, I forgot here a c. No, not yet the c. It's okay. So we arrived here. So here I have 3 over 2. So it's 2/3 of u 3 over 2 plus a constant. Then come back to your original variable. So square root of x, which is, so we will have x power 3 over 4 plus constant. Okay. Sorry, I did a mistake here. So my u, don't forget, our u is 1 plus x2, 3 over 2 plus c. So this is my answer. So you see how it is very practical and useful. Okay, similarly for the second example, we can deduce do similar calculus steps. So now, what about if I have a definite integral? Do I have something similar? Yes, we have something similar. Here it is. Okay, so we have another theorem that says the following. It says that if you have g prime continuous, so the derivative g prime is c0 on EV. F is continuous, f is c0 on the range of g. Okay, u is g of x. Then look what happens. The definite integral from a to b of f gx g prime x dx is equal to g at a, g at b, and fu du. Okay, and the proof is, yes, it's simple. is a simple one. It's good to see the techniques. So we showed previously that the integral from e to g of x, okay, g prime of x dx equal to a capital F at g of x from g at a to g at b, okay, which is so this is what we f at u, this is what we found, plus a constant, but yes, it's enough to take one antiderivative. We already know why. G at b minus a capital of g at a, okay, and yes, we can write it that is an antiderivative. We take the antiderivative of f from the two, okay, or for using the formula how fundamental theorem, it's exactly what we want, okay. So for example, let's do an example here, or yes, here an example. What about the indefinite integral dx over 3 minus 5x dx square, okay. So a simple way, yes, we can proceed like that. Set u, which is our g of x. I see here I will put 3 minus 5x, then du, I compute du, it's minus 5 dx. Then so I need to compute u. So the theorem says, let's start. So the theorem says it's u at 1, u at 2, yes, and du, fu du, okay. F is here 1 over x2, fu, u, fu, it's 1 over u square, yes, and du, okay. So it's the antiderivative will be u minus 2 plus 1 over minus 2 plus 1, okay. So let's redo it. So it will be u minus 2 plus 1 over u minus 2 plus 1, okay. Take u at 1, it's 3 minus u at 1, 3 minus 5 minus 2, u at 2, 3 minus 10, it's minus 7, okay. So at from u at 1, sorry, u equal to minus 2 to u equal to minus 7, okay, which gives us yes, it gives us 1 over 14 once you do all the calculation. But as a remark, I prefer find always an antiderivative than take in x. So find then because sometimes we forgot to change the endpoints. Okay. Last remark is about we have if f is an odd function, f is an even, so is even function, even is even on symmetric interval centered at 0. So it's important that you have this form of interval. Then the integral from a to a of fx dx will be equal 2 times the integral 0 to a of fx dx, okay. The integral f, if f is odd on the symmetric interval minus a, then the integral, okay, minus a to a of fx dx will be 0, Okay, and the proof uses change of variable u equal minus x. So you can do it as an exercise, use u equal minus x and write things well. So this is about the method substitution one. It's a simple idea, but it allows to do plenty of calculations. It simplifies lot of many calculations.